This is the presentation of Group 2 for Experiment Number 1, Familiarization of Fluids and Hydraulics Equipment. Now let's proceed to the discussion about the experiment. First, the objective of the experiment. This activity aims to familiarize students with the common fluid mechanics testing laboratory equipment. This activity helps students to understand and familiarize themselves with common laboratory equipment used in a hydraulics laboratory by identifying and drawing the following equipment and understanding the purpose of each piece of equipment. It is essential to become familiar with the laboratory apparatus to understand how to operate it properly, its purpose, and how to experiment appropriately, ensuring safety and accurate data interpretation. Clifton Watson, 2017. Metacentric height apparatus is a fundamental laboratory instrument used to determine the stability of a floating object or body. A higher metacentric height indicates greater stability but uncomfortable roll motion. It is essential to determine the stability of a floating body to ensure it will remain stable and return to its original position. Hasib Jamal, 2017. The hydrostatic pressure apparatus is a laboratory instrument used to determine the governing pressure exerted by a static fluid on a submerged object or body. Determination of hydrostatic pressure is particularly useful in designing dams, tanks, etc. Mazurek, D.F., 2015. Teaching Flume is a laboratory equipment that is designed to demonstrate the principles of water mechanics and visually investigate the behavior of open channel flows and hydraulic structures. Armfield, 2018. Bernoulli's theorem apparatus is used to demonstrate the energy conservation in flowing fluids. The equipment is also used to experimentally verify Bernoulli's principle in understanding fluid behavior by visual demonstration of pressure and velocity. Acumen Labware, 2025. Name: Metacentric height apparatus. The metacentric height apparatus is an essential hydraulic laboratory equipment used to help students determine the metacentric height of a floating body under both loaded and unloaded conditions. Metacentric height is a key parameter in understanding the stability of floating structures, such as ships, pontoons, and barges. Through this apparatus, students can observe how the position of the center of gravity affects the equilibrium of the floating body. By adding or removing weights and recording the resulting angles of tilt, they can calculate the metacentric height and analyze the stability behavior in different loading conditions. This hands-on activity allows students to connect theoretical principles of buoyancy, center of gravity, center of buoyancy, and metacenter with practical experimentation. It enhances their understanding of how design factors influence stability in real engineering applications, particularly in naval architecture, marine engineering, and civil engineering structures involving water. In addition, the use of this apparatus develops the students' skills in precise measurement, data interpretation, and application of stability concepts, which are crucial for ensuring safety and efficiency in floating structure design. Name: Hydrostatic pressure apparatus. The hydrostatic pressure apparatus is a fundamental laboratory instrument used to help students understand and determine the relationship between hydrostatic force acting on a surface when it is fully submerged and partially submerged in a fluid. It provides a practical way to verify theoretical principles of hydrostatics, particularly the magnitude, direction, and line of action of hydrostatic forces on plane surfaces. Through controlled experimentation, students can observe how the depth of immersion affects the resultant hydrostatic force and its point of application. By taking precise measurements and comparing experimental data with theoretical calculations, they gain a clearer understanding of concepts such as center of pressure, buoyancy, and fluid statics. This activity bridges theoretical knowledge with real-world application, enhancing students' comprehension of fluid behavior in hydraulic and civil engineering structures such as dams, gates, tanks, and submerged surfaces. Additionally, it develops their ability to perform accurate measurements, analyze data critically, and apply fundamental fluid mechanics principles to engineering problems. Name: Teaching Flume. The Teaching Flume is a versatile hydraulic laboratory apparatus designed to help students observe and analyze various open channel flow phenomena under controlled conditions. It allows students to understand the relationship between water level and flow rate above the crest of a weir and provides a clear visualization of critical flow and the characteristics of surface waves. Through hands-on experimentation, students can investigate how different flow conditions, such as subcritical, critical, and supercritical flow, develop in an open channel. They can measure flow depth, discharge, and velocity to verify theoretical hydraulic equations and flow principles. The flume also enables the study of hydraulic structures like weirs, sluice gates, and energy dissipators, illustrating how water behaves as it passes over and around these structures. This practical activity strengthens the student's understanding of key fluid mechanics concepts, including specific energy, flow transitions, and hydraulic jumps. It bridges theoretical knowledge with real-world engineering applications such as river engineering, irrigation systems, flood control structures, and water resource management. Moreover, using the teaching flume enhances students' skills in data collection, experimental analysis, and engineering interpretation, preparing them for more advanced studies and professional practice in the field of hydraulics and water resources engineering. Name: Bernoulli's Theorem Apparatus. The Bernoulli's Theorem Apparatus is a fundamental hydraulic laboratory equipment used to help students verify Bernoulli's principle experimentally and understand the relationship between different forms of energy in a flowing fluid. This apparatus allows students to determine and plot the total energy head versus distance along a streamline, demonstrating how energy is conserved in an ideal flow. Through the experiment, students can measure static head, velocity head, and total head at different points in the flow channel. By comparing these measured values, they can observe how the sum of pressure energy, kinetic energy, and potential energy remains constant, except for minor losses due to friction and turbulence. This activity provides a clear visualization of theoretical fluid mechanics principles and strengthens the student's understanding of energy conservation in fluid flow. It also helps them recognize and quantify head losses in real systems, which are essential considerations in the design of hydraulic structures and piping systems. Moreover, using this apparatus enhances students' data analysis, experimental measurement, and critical thinking skills, bridging the gap between theoretical concepts and practical engineering applications in areas such as water supply, pumping systems, and fluid transport systems. Name: Cavitation Apparatus. This equipment has been designed to elaborately explain the phenomenon of cavitation through demonstration. The lab setup consists of a test section which is made of acrylic and has conversion and diversion sections respectively. Pressure tapings are provided at critical pressure points to analyze the line pressure under experiment. A control valve is provided in the test section to regulate the water flow rate at upstream path. Two pressure gauges are connected to the pressure tapings which display the pressure at the time of flow passing through the test section. Name: Free Forced Vortex Apparatus. Description: The Free Vortex lab setup consists of a circular transparent cylindrical tank made of clear acrylic in which 4 jets are placed along the circumference of the cylinder at its bottom end. These jets help in the formation of free vortex. Theoretically, it is presumed that the torque exerted by these jets is negligible. A pointer is placed in transverse direction, horizontally and vertically across the full diameter of the vessel so as to measure the water surface profile. Both the axes have graduations so that the exact position of the pointer can be known. This experimental procedure involves measurement of the resulting free surface that is calculated by the variation of the sum of the pressure head and datum head. A drain pipe is provided to drain the vessel when not in use. The forced vortex experimental setup is an arrangement of a circular transparent cylindrical tank in which a plate is rotated with the help of a variable speed motor so that as a result the cylinder attached to the plate rotates on its vertical axis with the help of a V-belt and hence forced vortex is formed. An upper probe is placed in a transverse horizontally and vertically across the full diameter of the vessel so that water surface profile can be measured. Both axes contain graduations so that exact position of the probe can be recorded. This experimental procedure involves measurement of the resulting free surface that is calculated by the variation of the sum of the pressure head and datum head. A drain pipe is provided to drain the vessel when not in use. Name: Pitot Tube Setup. This lab apparatus is used to measure the local velocity at a given point in the flow stream. A pitot tube of internationally acceptable standard design made of copper or SS is supplied with the apparatus and is fitted below vernier scale. Placement of the vernier scale is designed to ensure that it can measure the position of pitot tube in a transparent section. The pipe is fitted with a flow control valve to regulate the flow. A differential water manometer is also provided to determine the velocity head. In conclusion, the experiment gave the students an idea on what to do when operating/using various equipment related to hydraulics and fluids mechanics. The knowledge gained in this experiment will help the students in the future when using such equipment, as it will not only improve their understanding, but it will also reduce the possibility of having accidents while using the equipment. Thank you for watching.